Today I will show and talk about this program, this new software that uses moving particle simulation method. And we will discuss how to use this software to reduce the development time as well as the number of prototypes. So overall, the cost in the prototyping stage in industry. In particular, we will talk about example of prototypes in lubrication and cooling of engines and transmissions. So this is the agenda of today's talk. First, I will introduce what is Particleworks and what's the methodology behind it, so the moving particle simulation. Then I will show some case studies from our customers regarding lubrication of gears. A test case we did with the Comer Industries, a company in Italy. And then we also will discuss about heat transfer, so the analysis of the cooling also due to oil or other liquids in e-motors or pistons. And for this, we will have two case studies with Drive System Design and Varsila regarding e-motors and the cooling of a piston for a naval engine. So, yeah, to introduce this software, Particleworks is a mesh-free method to solve Navier-Stokes equation. Compared to conventional CFD, it doesn't require the generation of a mesh, and this can really speed up the preparation of a model. So it really speeds up the simulation times. It's very nice tool to indeed study rotating elements interacting with the fluid. But also it's very nice to use for analysis of the splash or free surface flows. So when the surface of the liquid is really changing over time, as we see in this example, we have a splashing of some fluid in a tank that is moving on with some motion. So Particleworks really helps to distinguish all the free surface modifications. This software can also solve the motion of powder, so solid particles in the fluid, as well as rigid bodies interacting with the particles. So for instance, a boat that is floating on a river can be analyzed with this software. So regarding the application, I mentioned a couple already, but yeah, going into detail, we have the splashing of oil and the lubrication of transmissions, for instance, or also in more detail, the lubrication of some small elements, such as bearings in lubrication systems. In this case, we can also see that the fluid is non-Newtonian. So as I will say later, we can deal with highly viscous fluid as well. So then we can analyze the cooling effect of oil or other fluids on engine and pistons or in heat drives machineries. We can also analyze water jets on hydro turbines or Pelton turbines to understand the torque or other efficiency-related aspects of those systems. And as I mentioned, we can deal with the different type of fluids, chocolate, glue, cement. So we can also span over different, let's say, application and different industries. So to introduce the test cases, let me show you a video about a project we had with Marelli Motori. The video speaks for itself. So as we saw in this simulation, our customer was able to quickly develop a prototyping element, and was also able to understand what was the behavior in some areas that were not accessible experimentally. So the first test case we will see is from Comer Industries. This a company produces let's say powertrain in different vehicles. For instance, in this case, a wheel loader. We have the coupling gearbox that couples the electric motor with the axle, and in this study they wanted to analyze this gearbox. In particular, they wanted to understand what was the lubrication of the system at different rotating speed, and also in different rotation orientation, so clockwise or counterclockwise, and also in different angles, so tilting angle of the element itself. So as I said, the targets was first to understand the lubrication of the system, but then also to optimize the level to reduce and minimize the power losses due to the churning of the oil itself. So in this study, we can see the model in this slide, and also a real-life lab experiment. We can see through the clear case the lubrication of the element of the gearbox. In particular, in this zoom, we a very clear difference between the lubrication of the middle bearings, the bearings in the middle, compared to the one on the top. And this relationship, we can see the relationship between the experimental observation and also the simulated gearbox. In fact, we can see that this element is very well lubricated, while this one is not. So to validate this type of analysis, Comer set a scale on the lubrication of particular elements. In particular, a scale of 1, it's a very poorly lubricated element, while a scale of 4 means that the element is submerged by the oil, basically. So in the study, they compare different working conditions, and they saw that there was a good agreement between the test data and those data that were coming from the simulation themselves. So we can see that indeed, where the simulation suggested that the area was really poor lubricated, also the test was telling the same. So moving forward and discussing about the cooling and the thermal analysis that can be done with Particleworks. The first test case I want to discuss is this one with drive system design based in UK. The results from this analysis are also collected in the paper that is shown here. So if you are interested, you can download it on the website of EngineSoft. So they wanted to optimize the thermal cooling effect in e-drives. If we can analyze the system, so we have this rotor in the center that is, of course, rotating against a stator and some windings. And regarding the oil injections area, we had 4 in the middle part, rotating middle part, and 2 at in the upper part of the windings. So in this study, they wanted first to understand what was the oil distribution. In this image, in this video, you will see in bluish, the oil volume, while in pink, there is air. So there is also a combination of the two materials, two fluid-like materials or particle materials. And once the simulation was done, so once we could understand what was the distribution of the oil in the system, we could extract the value of the heat map, so the heat transmission coefficient, the heat transmission coefficient on the walls. And once we had this data, we could simulate through ANSYS the temperature developed inside the e-motor itself. So we could understand what were the critical area with higher temperature in the system itself. It's important to underline and highlight that this type of simulation were done in just a few days. In fact, 3 different setups, 3 different conditions were tested in 1 week, already providing very important information how to further develop the prototype. So in conclusion, as a last test case, we see this the cooling of a piston in a naval engine from Varsila. In this case, we use oil. We wanted to investigate the oil effect only on the cooling, not the lubricating effect on the piston itself. In particular, they were interested in understanding in this small gallery how the oil will spread and let's say stay during the simulation. And they also wanted to validate those simulation with real-life experiments. In fact, they placed on the geometry various thermocouples. You can see here all the numbers are various thermocouples placed close to sensible points. As you can see, there is a very good correlation between the local temperature predicted by the simulation and the measured one. So after this validation step, they actually ran multiple simulations at different loads, so in different conditions. And in all of them, we can see that there is a good correlation between the measured and the simulated temperature, especially in the higher range that is the most critical range. There is a very, very good correlation. So to summarize, Particleworks is a type of moving particle method, is a type of software that uses MPS, moving particle simulation, to solve different studies and different case studies that are important in industry. It's a mesh-free, so setting up a case is usually very quick, and it can give results about some prototypes in very short amount of time. So we saw the application of this method in the analysis of the oil distribution in a system, as well as the flow rates between specific areas in the system itself. We also could use this type of analysis to understand what are the churning losses that the oil cause in the system. And we can also perform with this type of analysis the temperature development in the system and the cooling effect of the oil or other fluids. So this was all I had to say. I hope you like it, and thank you for the attention.